Hello friends. So in this example of creating a new MCP server, we are going to look at the example where we will connect this MCP server with a database which is a SQLite, and we are going to develop a simple order processing MCP server with modular architecture. So far we were just writing the code in a single server.py file, but here I will explain the modularity, the architecture that we are going to utilize for developing this MCP server so that we can maintain the code easy. This is the practical example so that in future when you create your own MCP server, you can utilize this understanding to create a real life project. So first, this is our server.py, which is a main server which handles all the orchestration and request routing. Then we have a database.py file which is having all the code that is written in Python for performing all the database operation with SQLite. Then we have the MCP protocol which handles all the communication and the related messages. Then we have the order service, which is a core business logic for our order management, which would be utilized by our database and server. We are having one more py file which is resource handlers. We are using MCP resources which will help us to utilize the power of resources where the user can input the uh, natural language processing prompts which can be understood and can be served by these resources. We will have the basic tools as well for performing the operations like adding the order, updating the order. We have the orders.db file which is in the project structure itself, and we have this readme md file. So this is the readme file which I'm going to attach with this session, right? Which will explain each and every purpose of the py file that we have created, but this part is important. So when the MCP client request comes through the cursor AI, for example, it goes to server.py, which is our order processing server. It will then go to MCP protocol, which handles all the operations related to MCP. Now, based on the prompt, it will decide whether it needs to serve the request through the resource handlers or tool handlers based on the request after it interprets the prompt. Then both of them uses order service to serve the actual prompt, and database.py is actually used in order service for performing the operation related to the database from the SQLite. The benefits of this architecture: we have knowledge of separation of concern for sure, code reusability if we want, the maintainability is very easy, we can test the individual py files separately, and the scalability, right? We can modify the existing files without impacting the entire project. And this is the usage: you can directly run the server through python server.py, or you can configure the MCP JSON entry and run the respective MCP server, enable it. Here you can see it has three respective tools and the seven resources which I have mentioned. So let's go into our server.py. Here the server.py utilizes the dependent local libraries that we have created, like MCP protocol, order service, resource handlers, or tool handlers. So this is a class of order processing server. This is the initialization process. When the server will be started, this is the initialization process. When you will first run this example, then it will create the database file automatically and create the schema as well. It creates the instance of the order service, the instance of resource handlers, and the tool handlers. And this is the respective handler for handling all the requests related to listing, resource read operation, tool list operation, which will be provided to the respective client when it will identify what is the different tools and resources which are supported by this MCP server, right? So this is how the code is created and this is how we run it. Let's see this database.py file. So it utilizes the local orders.db. This is the database manager class, right, which initializes the database. connects the database, creates the instance of the cursor object, and if database's schema for the order is not present, it will create it, right? And all the operations related to adding the order, updating, and all this. So I have also created one prompts samples.md, right, which I'm going to attach. So let's first add a new order, right? Add a new order for Jack with product mobile for quantity 1 and price is this. So it should identify the tools, right? So it is identified and it is executed, right? So this way the tool was executed, right? So let's try the resources. Display the complete order list, display the complete orders list. So it should display all the orders, so you can see the search orders resources being used over here, and all the orders details are displayed over here. And we can query the respective record as well. We can have the order statistics as well. So let's run the prompt. Give me analytics on orders. So this basically goes to our resource server, resource handler that we have created, and it ultimately sends the respective query to the database, which is executed by order service. So you can see over here the complete analysis of all the data that we have, right? Mobiles, module, right? Laptop, high value orders, completion rate, correct? So let's see our resource handler. So you can see this resource handler handles all the requests. These all are the resource handlers that are supported over here, and ultimately it goes to the respective order service for querying it. You can see order all, handle all orders, right? Handle pending orders. So these are all handlers which we have created, which ultimately uses this order service and calls the respective function for get all orders, get recent orders, right, get pending orders. So if it reaches to get pending orders, right, it will go to this database.py file, which, which will establish the connection, and it will run the query. So the client sends the simple prompts which will be identified whether the tools need to be executed or the resources need to be executed. And this is how we have understood the modularity, the simplification that we have implemented, and structuring the respective files with a well-defined architecture. I hope you have understood that we can utilize Python with the development of MCP and utilize the power of tools and resources for achieving the communication between database. Thank you.